Why are combustion engines less fuel efficient? Have you ever wondered why your car's engine doesn't convert all the fuel into motion? Let's break down the reasons behind the fuel efficiency of internal combustion engines. At the heart of combustion engines is the process of burning fuel to create high-temperature gases. These gases push pistons or turn turbines to generate power. However, the efficiency of this process is limited by thermodynamics. The efficiency of any heat engine relies on the temperature difference between the hot gases and the cooler surroundings. The greater this difference, the better the potential efficiency. But here's the catch. Internal combustion engines cannot reach extremely high temperatures without causing damage. This limitation restricts how hot the gases can get during combustion. When temperatures rise too high, issues like knocking can occur, which is when fuel ignites too early. This means that the maximum temperature and pressure achievable are capped, limiting overall efficiency. Additionally, the thermodynamic cycles used in these engines, like the Otto cycle for gasoline engines or the diesel cycle for diesel engines, have stages where energy is lost. During combustion, not all the chemical energy in the fuel turns into thermal energy. Some energy escapes as heat to the engine walls and exhaust gases. When the gas expands to do work on the piston, some energy remains in the exhaust and is not recovered. This happens because the expansion process cannot be perfectly controlled. Mechanical losses also play a role. Friction between moving parts consumes energy, as does the operation of auxiliary systems like pumps and fans. These mechanical inefficiencies further reduce the useful work output of the engine. Another reason for lower efficiency is incomplete combustion. In real-world engines, the fuel-air mixture may not burn completely or evenly. This leads to wasted fuel and lower efficiency. The speed and timing of combustion are critical. If combustion is slow or poorly timed, energy conversion suffers. The compression ratio, which is the ratio of the maximum to minimum volume in the cylinder, is another important factor. Higher compression ratios can improve efficiency by increasing the temperature difference during the cycle. However, if the compression is too high, it can cause knocking, which requires higher octane fuels to prevent premature ignition. To sum it up, combustion engines are less fuel efficient due to several factors. Thermodynamic limits restrict maximum temperature and pressure. Heat losses occur to engine components and exhaust gases. Mechanical friction and auxiliary loads consume energy. Combustion is often incomplete or poorly timed. And compression ratios are limited by fuel properties and engine design. Typically, gasoline engines achieve thermal efficiency of around 25 to 30%, while diesel engines can be slightly higher, but both are far from perfect. Understanding these principles helps us see why improving fuel efficiency is a challenge that requires advancements in engine design and combustion control.